Let's take a look at factoring by grouping. Factoring by grouping is the process that you'll use anytime you're factoring a four-term polynomial. For now, we're not going to worry too much about prime polynomials that can't be factored. We'll worry about those more next week. The process for factoring by grouping is pretty standard, and if you can learn the process, you really can factor any four-term polynomial. And it's important that you learn this because we're going to use it to help us to factor three-term polynomials when they aren't easy to get to factor by guessing. So let's say, for example, we wanted to factor 4x to the fourth plus 8x to the third plus 3x squared plus 6x. So the first thing that we're going to do is we're going to split the polynomial into two groups. In this case, our first group is 4x to the fourth plus 8x to the third, and our second group is 3x squared plus 6x. Once we split it into groups, the first step is to factor the GCF out of the first group. So if we look at our first group, if we look at the two coefficients, 4 and 8, the largest number that goes into those two is 4. Between x to the fourth and x to the third, the largest value that goes into both is x to the third. So the GCF in the first group is 4x to the third. And we're going to factor it out, and we're going to be left with x plus 2. Okay? Anytime you make a decision in factoring, go ahead and check it, because you know you're guessing. So check, make sure it works, and then move on to the next step. That way you don't get too far into the problem before you realize that you made a mistake in the first step. So 4x to the third times x is 4x to the fourth. 4x to the third times 2 is 8x to the third. We're good. The next step is a little unusual, but bear with me. You'll see why we do this in the next example. You're going to rewrite the second group this time, but the only thing you're concerned with is making sure that what goes inside the parentheses matches. It has to match. So in this case, that gives us 4x to the third times x plus 2 plus something times x plus 2. The next step is to figure out what goes on that line. So we want to ask ourselves a question. Is there something that I could put on the line that would then distribute and give me the second group? And in this case, yes, there is. 3x would work. So if I was to change what's on the line, or if I was to change the line into 3x, now I can look at my second group and I have 3x times x, there's my 3x squared, and 3x times 2, there's 6x. So I know that this polynomial that I've written right now is equivalent to the original polynomial. Am I factored? No. This is not a product, this is a sum. So because it's a sum, it's not factored yet. The next step, now I should factor it. And the reason why we needed the parentheses to match is because now, instead of a four-term polynomial, I have a binomial. The first term is 4x to the third times x plus 2, and the second term is 3x times x plus 2. The x plus 2 portion of each term is common, and so I do have a GCF in this binomial. The GCF in this case is x plus 2. And if I factor it out, I end up with x plus 2, my GCF, times everything that's left, 4x to the third plus 3x. Anytime we're factoring, we're always guessing, and so we should always check. We check by multiplication. So using FOIL, f is first, gives me 4x to the third times x, there's my 4x to the fourth. My outer is 3x times x, there's 3x squared. My inner is 8x to the third, and my last is 6x. So even though the terms are in different orders, it works because the commutative property says order doesn't matter when I'm adding things together. And so in this case, I'm done, and I factored this by grouping. Let's look at a little bit more complicated of an example. Let's factor 3x to the fifth plus 5x to the fourth minus 6x squared minus 10x. And again, the first step is to split the polynomial into two groups. So in this case, our two groups are going to be 3x to the fifth plus 5x to the fourth. And then because of the negative signs, it's easier to just go ahead and consider that to all be my second group, negative 6x squared minus 10x. Once again, factor the GCF out of the first group. So in this case, There's no number that goes into both 3 and 5, so my greatest common factor in my first group is x to the fourth, and I'm left with 3x plus 5. And again, I made a decision. I'm going to check. X to the fourth times 3x is 3x to the fifth. X to the fourth times 5 is 5x to the fourth, so I'm good. My polynomial is equivalent to the original polynomial. Here's why we want to rewrite the parentheses of the second group to match the first group. Because in the next step, all I care about is making sure that I can factor out what's inside the parentheses as a GCF. So it has to match. In this case, I'm going to have x to the fourth times 3x plus 5 plus something times 3x plus 5. And again, I want to ask myself the question, is there something I could write on that line that is going to give me, when I distribute, negative 6x squared minus 10x? And in this case, yes. If I change what's on the line to be negative 2x, now negative 2x times 3x, there's my negative 6x squared. And negative 2x times 5, there's my negative 10x. And so what's written there is equivalent to the original polynomial. Again, we needed to have what was in the parentheses match. That was the most important part because now we're going to factor it out as a GCF. And when I factor it out, I end up with 3x plus 5, there's my GCF, times everything else, x to the fourth minus 2x. If we check, x to the fourth times 3x, there's my 3x to the fifth. My outer gives me 5x to the fourth. My inner gives me negative 6x squared. And my last gives me negative 10x. So my check is good. Make sure you're always checking. It's really easy to make mistakes in these without really recognizing that you've made a mistake.